I was thinking about what other features of the 4-jaw chuck that I could demonstrate, and I was looking through the scrap box, and I came across this chunk of metal here, aluminum, probably just a piece of scrap I picked up along with some other stuff at a junkyard, or probably cut off of a larger piece of something. As you can see, it's been sawed off here. But I thought, well, this would be interesting. Suppose we just pick this piece and see what we can do with it. So I laid out this little plan here, and the idea is to end up with a plate, and I'm going to bore 2 holes in it. This one is 1.2 inches in diameter, and then another hole 0.70 inches in diameter. And I deliberately chose those to be non-standard drill bit sizes so that I can show how to do the boring operation using the 4-jaw chuck. This one edge tapers down to a very thin cross section, so it starts out sort of like a wedge and then tapers down. So it's a fairly bizarre shape. So I want to cut off most of this part here because it's too thin to really fit into our plan, and then I've got to bring this thing into a more or less smooth and flat piece of work before we start doing the holes. For my first operation, I want to trim down this edge. I want to cut back here about 1/4 of an inch or so. But you can see I've got this clamped in the 4-jaw chuck. I have 2 of the jaws using the so-called outside configuration so that I can grip on these ends, and then the other 2 jaws are using the inside configuration. And you'll see later on in this process we'll be using all 4 jaws to grip in the outside configuration. I've got this pretty securely clamped in here, and because this extends out pretty far and I've got a relatively small surface to grip on, there's a real risk of this popping out here and breaking loose. So I'm going to take very light cuts to begin with. This is also going to be an interrupted cut because this is not a smooth surface. So initially we're going to be cutting more on this edge because it sticks out more, and then eventually we'll be cutting on the whole edge. So naturally I want to have my safety glasses on in case that thing comes popping out of there. I think I'll use my safety shield too. But we quickly run into our first problem, and that is that I can't get the tip of the tool far enough back to clear this edge. And the reason is that I've got my compound set parallel to the ways, but you can see if I swing it around this way and it's more common orientation, that's going to push the tool even farther in. So what I need to do is tilt the compound back this way, which will bring the tool post farther away from the work and give me the extra clearance that I need. Alright, now I've adjusted the compound angle to give me the clearance I need, and I decided to go ahead and move the tailstock out of the way. Just that'll give me more room to work with my hand back here. But this is a 7x16 lathe, so it has the longest bed length available in the 7X lathe series. But these marks here show some of the other sizes: 7x14, 7x12, and 7x10, which is actually a 7x8 if you've seen my comments on that elsewhere. So depending on which model lathe you have, you may not have much room out here to work. But we have enough to get the job done on this machine, so let's go ahead and get set up for that. I have a carriage lock on this lathe, and I decided to go ahead and lock the carriage down, and I'll use the compound feed to move the cutting tool inward as needed, and then we'll feed across with the cross slide to make our cut up to the center. Alright, that looks like it's about ready to go. Let me get my safety shield in place here, and we'll start out slowly. I want to make sure I'm clear of the work. I am, and I've already checked to make sure this is held in here tightly and securely. I want to start out with a pretty slow speed. I don't know what it is, but it's maybe on the order of 400 RPM. And I'm going to bring the tool in a little closer, and now I'll slowly feed in with the compound until it just starts to touch. Make sure my tool is locked. There we go. Okay. So as you can hear, this is a highly interrupted cut. We're only cutting on maybe 10% or less of the rotation. Now, an interrupted cut like that also can create more force on the workpiece than an ordinary cut. So there again, we have to be careful to take light cuts initially. So I'll feed a little more in. And we're just chipping the metal off that edge now. As I get in a little ways, you can hear the sound stops, and that's because we're removing some of that edge that was sticking farther out. As we get closer into the center, the edge recedes or doesn't stick out as much. Now you can see we're cutting much farther in now. Maybe all the way to the center. Not quite all the way to the center. Well, as you can see, this is kind of repetitive and not terribly interesting after the first few cuts. So I'm going to do some more work off camera to get it farther down, and then we'll come back. I did want to comment, I'm using a shop ground high-speed steel tool for this operation, and for an interrupted cut like this, high-speed steel is a good choice. Carbide has a tendency to fracture when you're doing interrupted cuts like this, so you probably would not want to use a carbide tool for this. Now obviously this is a slow and inefficient way to go about this if you have other choices. Obviously, if I had a mill, which I do, of course, or a bandsaw, I probably would, if I was just working to get the job done rather than to illustrate a point, I would go ahead and trim this edge off with the bandsaw and then use the mill to put a smooth finish on it. So I wanted to show you that there are some things you can do that, although they're not the most efficient or the best way to do them, if a lathe with a 4-jaw chuck is the best tool you have for the job, you can sometimes get it done. But the important thing is you only want to do that if it's safe, and I would not recommend this process to a beginner. Well, after several more passes, I've whittled the this side of the workpiece down far enough, and I want to flip it over and work on the opposite side, and then probably go back to this side to bring it to its final dimension. I first want to get a clean edge on the opposite side, but I'm then going to bring it to final dimension on this edge so I can remove as much of this low area here as possible. I'll loosen the number 2 jaw and the number 1 jaw, and we'll flip it over so that the new edge is now exposed. We have to clamp down here. We've got a thinner cross section here to work with, so I'm going to try to roughly center that between the jaw number 1 and jaw number 3. And I'm just checking to see that these 2 jaws are extending beyond the edge of the chuck by approximately the same amount. That will get us close enough. I'm going to tighten it down all around. Feels good and secure now. So as you can see, we didn't get the whole surface yet, so we need to make a slightly deeper cut. Alright, it looks like we've got just about the whole surface done now. I think it's all the way across. I think I'm going to take one more light pass before we call it done. Okay, I think that's good enough for now. Looks pretty good. Let's take some measurements here and see how it looks. about 1.592 at this end. Let's check the opposite end. About 1.595. Not too bad. As we clean up this edge some more, it will hopefully end up within 1/1000th on both ends. But considering how rough this workpiece was to begin with, this is pretty good at this stage. So my plan is to go from 1.954 down to 1.510. So we're going to remove 84 thousandths, and we'll feed the, well, we'll have to take a look at the compound, because right now it's at an angle and it may need to remain at an angle in order to reach out far enough on the workpiece. But with it at an angle as it is right now, you can't measure directly using this hand wheel scale here, so have to think about that for a minute. Our final dimension in the long direction here is going to be 2.75, so we can take off, looks like about 1/4 of an inch here, and by making it shorter overall, then maybe I can swing the compound back around so that it's parallel with the ways and still reach all the way out to the ends. So we'll go ahead and shorten it and then put it back in and see where that takes us. Well, since I don't have a lot of extra material, I decided I'd better put a Sharpie mark there just as a guide so I don't overshoot. So I don't want to cut down into the Sharpie marker. So now our procedure is basically the same as before. I wanted to show you the technique I'm using here for feeding the cross slide in. You can use either one hand or two hands, but I tend to use two. I keep my gibs fairly tight, which avoids chatter, but it makes it a little hard to move the cross slide in and out. With two hands, you can get a smoother feed. And it's also a little less tearing. Depending on how the work sounds, you can adjust your speed a little slower, a little faster. If it's starting to feel like you're taking too deep a cut, you can slow the feed down. You can see some vibration here. It's a pretty deep cut. So I get in towards the center. Alright. This will be my last cut on this side. I'm going to use a slightly higher RPM and just take off a few thousandths, maybe about 5 thousandths, and get a smoother surface finish. Not too bad. When you're making interrupted cuts like this, you need to keep an eye on the sharpness of your tool bit, because the constant pounding of the work against the tip can sometimes cause it to wear down a lot more quickly than it typically does. Particularly if you're working with material like cast iron, it will dull the tip very quickly. So you just need to check that and make sure it's staying reasonably sharp so you'll get a good surface finish. Looks okay for now. I'm getting some pretty sharp edges on this workpiece now. I'm going to just touch it up with a small file to mainly for safety so they don't get cut, but also it will help it to seat more evenly in the chuck. Well, here's our workpiece now. It's starting to look reasonably like a rectangle compared to where we started. Let's see what the length is. It's about 2.83. and our target is 2.75. So we'll flip it around now, we'll put this end in, and then we'll trim it down, probably not to the final dimension, but close to the final dimension. I'm going to put it back in. I'll put this side in the chuck this time. We'll take a little bit off of this end, but probably not. Probably won't bring it to final dimension just yet. I think I'll probably do that after I smooth off these two faces. You may notice for the first time in a while I'm wearing a long sleeve shirt. The remnants of Hurricane Michael came through Virginia last night, and the temperature dropped from the 80s, and it's right now it's down in the 50s. So I did want to mention, when you're wearing long sleeve shirts, obviously you want them rolled up or tied back, or something like these cuffs, which will keep them from dangling down into the work. So but be very conscious when you have a long sleeve shirt now, as we're getting into the cooler weather, to make sure it's not going to get caught on anything. Since we want to measure the depth of our cut at this point, I want to swing the compound back around so that it's parallel with the ways. Because I'm going to be advancing the compound to measure our depth of cut, I want the compound to be back somewhat on the dovetails so that I have plenty of room to move ahead without reaching the end of the lead screw. So bring it up so the tool's touching the work, lock the carriage, and now we're zeroed here. Now we can just read in our depth, which is going to be 50 thousandths, so right from the dial. And before I start up the lathe, I want to make sure that I move the cutting tool back away from the face there so it doesn't get caught up when I start the lathe. I'm going to feed in 20 thousandths for our first cut. I'll take another 20. And then we'll just take 10 on this last pass. Okay, let's take it out and double check our measurement. Looks pretty nice. And let's measure the length here, see where we're at. Alright, it's measuring at about 2.784 or 2.783, so that gives us about 33 thousandths to work with later. Now, one concern I have is when I put the workpiece back in this orientation, whether I can get the tool post back far enough so that I can use the compound parallel to the ways and therefore measure the distance. But I'm going to leave that question unanswered for the moment, and I'm going to go ahead and work on this face here.